Hello students, in the previous video we have seen the Mendeleev's periodic table, and in continuation in this video we will see the modern periodic table. What is the modern periodic table, how it helps us in our studies. So this is our topic today. Keep watching. The modern periodic table. The modern periodic table is based on the modern periodic law. This law was proposed by a scientist called Moseley. Moseley is the scientist who proposed the modern periodic table. According to him, the law proposed by Moseley, called the modern periodic law, states that physical and chemical properties of elements are the periodic functions of their atomic numbers. Now the term numbers, this is the only difference from the Mendeleev's periodic law. Mendeleev said physical and chemical properties of elements are periodic functions of their atomic weights. Now Moseley modified it into numbers. So on the basis of this law, if we arrange elements in the increasing order of their atomic numbers, elements with similar properties appear at regular intervals. That is the meaning of the modern periodic law proposed by Moseley. Now the key factor here is that atomic number is the criterion for classification of elements. So the major contribution of Moseley is that atomic number and not atomic weight, atomic number Z and not atomic weight A. So this is the criterion for classification. Now this is what Moseley proposed. Now the properties of elements, as we know, depend upon the valence electrons, the number of valence electrons present in the valence shell. That is, in other words, it is electronic configuration. We get valence electron only from electronic configuration. And now the electronic configuration is based on the atomic number. So this is the key factor of the modern periodic law proposed by Moseley. So we know atomic number determines the number of valence electrons from the electronic configuration, and that determines the properties of elements. So elements should be arranged on the basis of their atomic number and not on the basis of atomic weights. This is the highlight of the Moseley's modern periodic law. Now in the modern periodic table, there are 7 horizontal rows and 18 vertical columns. 7 horizontal rows, 18 vertical columns. As we know, the horizontal rows are periods, and the numbers used for representation of the periods, the Roman numbers 1A to 7A were used in the old system and denoting groups 1 to 18. But now in the modern system, we have introduced the Indo-Arabic numerals, that is numbers 1 to 18, to denote the groups. Now if you talk about the periods, periods are horizontal rows. The 7 horizontal rows in the modern periodic table is known as periods. Now we have special names for each of these depending on their capacity, because the first one is the shortest period, which has only 2 elements in it. The first period has 2 elements, known as shortest. Second one has 8 elements, and third also has 8 elements. So both are known as short periods. These are short periods. And then we have the 4th and the 5th with 18 elements each. They are known as long periods. And we have the 6th and the 7th period with 32 elements each, which are known as the longest periods. So this is about the periods in the modern periodic table. Then there are some features that we can see in the along the periods. Now the modern periodic table, moving from left to right, the atomic numbers, the symbols, electronic configuration, all this has been given in this table. I have made this table where you can see the first element hydrogen is here, the next helium is placed here. Now here the numbering is 1, 2, 13, 14, 15, 16, 17 and 18. And the Roman numbers, the old system, 1A, 2A, 3A, 4A, 5A, 6A, 7A and 0. This is the old system. Now if you see the complete modern periodic table, you see here, this is group 1, 2, that is 2A, and 3, 4, 5, 6. This particular group, the part of this is the transition metals or the D block, is ignored for our study. So as per syllabus in class 10, we don't study these elements. So after 2, we are going to 13 here. We are not discussing these elements. Okay. So that is what you see here, 1, 2, and then comes 13, 14, 15, 16, 17, and 18. So the elements are here: hydrogen, lithium, sodium, and beryllium and magnesium, boron and aluminium, carbon and silicon, nitrogen and phosphorus, oxygen and sulfur, fluorine and chlorine, and then here helium, neon, and argon. So this is how the elements are arranged. The next thing is across a period. There are certain features that we can see across a period. This is what we are going to discuss in detail. This is something important that you must remember these facts. So I'll show you these facts one by one. The first thing is atomic number increases by 1. If you check atomic number 1, and here it is 2, then 3, 4, 5, 6, 7, 8, 9, 10. So we are talking about across a period, means left to right. Left to right. If you move from left side to right side of the periodic table, what you will see, atomic number increases by 1, 1 and 2, 3, 4, 5, 6, 7, 8. If you start here, 11, 12, 13. So it goes on increasing by 1 addition every time. Second thing is number of valence electrons increase by 1. If you check the number of valence electron, 2, 1, here the valence electron is 1. In the next one, the valence electron is 2. Then valence electron is 3. Valence electron 4, 5, 6, 7, 8. So this is how it increases. And the next period again starts with 1, 2, 3, 4, 5, 6, 7 and 8. So valence electrons increase by 1 across a period. Next thing is number of orbits remains the same across a period. Left to right, if you move, the first one you take, configuration is 1 and 2. That means there is only one orbit with 1 electron. Here only one orbit with 2 electrons. That means from in period 1, all the elements have 1 orbit. Yes. Second period you take, all of them will have 2 orbits each. 2. Here also 2 orbits, first orbit, second orbit, first orbit, second orbit, 2 orbits. All of them have 2 orbits. This is the second period. 2 orbits. Each of them have 2 orbits. Third period, all of them have 3 orbits. So this is what you can see next. Number of orbits remains the same. Next point is number of orbits is equal to the period number. That's what I said. Period 1 will have only 1 orbit. Period 2 will have 2 orbits. Period 3, all of them will have 3 orbits. You can see that from the electronic configuration. Then metallic character decreases and non-metallic character increases. Yes. So if you check from left to right, the metallic character is decreasing. Lithium is a strong metal. It's a light metal, and this is the metalloid, non-metal and non-metal, strong non-metal, very strong non-metal. This way it is increasing. Here again strong metal. This is a strong metal and light metal. Then metalloid, then non-metal, non-metal, strong non-metal. So this way metallic character goes on decreasing from left to right. Non-metallic character goes on increasing from left to right. Next is the outermost orbit, that is the valence shell of the last element of each period, is complete with 8 valence electrons. In the case of helium it is 2. So see the outermost one, 2, 8. This is 2, 8, 8. They have complete outer orbit. Valence shell is complete with electron. The first one, this has only 1 orbit. First orbit can have maximum of 2. So that is also complete with 2 electrons. In other words, we can say helium has a duplet configuration. And these, all the rest of them in the 18th group have octet configuration. Octet configuration. So that is complete. Now next is the valency increases from 1 to 4 and then decreases to 0. If you check each of these from left to right, the first group valence electron is 1. They lose 1 electron and form plus 1 valency, that is valence 1. And the second group, they have 2 valence electrons. So they lose 2 electrons and reach plus 2 state or valency 2. And third, they have 3 electrons, so can lose 3 electrons, valency 3. Fourth group, they have 4 electrons. They will share other 4 electrons to reach octet, so valency is 4. And the fifth one, 15th group, so here they have 5 valence electrons. They will gain 3 electrons or share 3 electrons, so valency is 3 and they reach octet. The 16th group, 6 valence electrons are present. They will share or gain 2 electrons to reach stable configuration. So valency is 2. And 17th group have 7 valence electron. They will gain or share 1 electron. So to reach stability, so the valency is 1. Now the 18th group, complete outer orbit, they do not share, they do not lose or gain electron, valency is 0. That is the meaning of this. Valency increases from 1 to 4 and then decreases to 0. 1 to 4 then decreases to 0 across a period. So these are the properties of elements across a period in the modern periodic table. The next is characteristics of elements in group in period 1. The first period has 2 elements, hydrogen and helium. Check this. Hydrogen and helium. Atomic number 1 and 2. The electronic configuration of hydrogen is 1, electronic configuration of helium is 2. And the nature is, this is a non-metal, this is a noble gas, valency has 1 and this one has 0 valency. This is about the first period. Now as we have been talking about periods, let's go into the second period. What about the second period? In the second period we have the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now here we have the atomic numbers starting from 3, 4, 5, 6, 7, 8, 9 and 10. So if you write the configuration, 3 means 2, 1, 4 means 2, 2 and 5 means 2, 3, 6 means 2, 4, 7 means 2, 5, 8 means 2, 6, 9 means 2, 9 and 10 means 2, 8. So we have the electronic configuration. This has 1 valence electron, metal, valency is 1. 2 valence electron, it's a metal, valency 2. 3 valence electron, this boron is a metalloid and has a valency of 3. And now this has 4 valence electrons and it is a non-metal with valency 4. Nitrogen, 5 valence electrons, non-metal, valency 3. Oxygen, 6 valence electrons, non-metal, valency 2. And fluorine, 9 electrons, 9 atomic number, that is 9 electrons, configuration is 2, 7, valence electron 7, it will gain or share 1 electron, so valency is 1, it's a non-metal. Noble gases, this is 2, this is neon, 10 means 2, 8, the valence electrons are 8, complete outer shell, it's a noble gas and valence is 0. This is the third period. Now if you check the second period. Now if you check the third period, in the third period we find sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon the same way. Now here we have 11, 12, 13, 14, 15, 16, 17 and 18. These are the atomic numbers of these elements. Electronic configuration of sodium 281, it's a metal with the valency 1. Magnesium, the valence electron is 2, metal, valency is 2. Come on, say what about aluminum? Valence electron is 3, therefore it's metal, valency is 3. 14, silicon is 14, 284, valence electron 4, valency 4, it's a metalloid. And phosphorus 15, 285, non-metal, valency 3. Sulfur 16, 286, non-metal, valency 2, because it will gain or share 2 electrons to reach octet. Now chlorine, 7 valence electron, it needs 1 more electron. So valency is 1, non-metal, is a noble gas, 8, 0. So this is about the modern periodic table and we have discussed the periods in the modern periodic table. So friends, I hope you understood this, and if you have questions you can write it on the comments and subscribe the channel and like it. Thank you.